Hey, pre-calc students, Mr. Mitchell here. We're going to take a look at inverse trig functions today. We're going to be looking at what an inverse trig function is and how to work with it. So some of the definition beginning part is just dealing with some domain and range type issues and being able to read what it's representing. So we talk about the inverse sign or the arc sign. They really do mean the same thing. Okay. Typically, when we talk about inverse sign, we're focusing more with triangle type questions. When we talk about arc sign, we're usually focused on more questions that deal in radians, but they really do mean exactly the same thing. Okay. And what they really mean is the sign of y equals x. You're switching x and y, really. Your angle is becoming your sides, and your sides are becoming your angle, if you want to think about it that way. Up until now, we've really been finding the sine or cosine or tangent of an angle and finding the ratio of the sides that make up the triangle. When I say the ratio of the sides, I mean SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Now we're going to take a look at taking the sides and figuring out what the angle is. Okay, so again, here's some definition type stuff. So we're looking at the arc sine of -1/2. So we're really trying to figure out what angle makes -1/2 be the sides. And so we have a negative. So we have to think of, all students take calculus. All right. Remember our drawing of all students take calculus. We have to bring that back into play. And then we also have to take into account some of our domain restrictions. So what we're going to highlight here first is that between sine and tangent, you're either in the first quadrant, okay, and that's because it's positive. So it's positive in the first, or see how it goes into the negative side? That means you're in the fourth quadrant. That's when you're negative. For the cosine, the way it's written here, okay, your domain for cosine is really in the first, and that's positive, or you can be in the second, and that's when it's a negative. Okay, so because there's certain domain restrictions, that we don't have domain restrictions for sine and cosine for just a regular trig function, but when you do the inverses, you have to, otherwise it doesn't make a function. Okay, you violate the function condition. So to make it true, to make it a true function, we limit it into certain quadrants. So again, for sine and tangent, you're either in the first or the fourth, and for cosine, you're either in the first or the second. Okay, so knowing that sine is negative, okay, that means you have to be in the fourth quadrant. The inverse, the arc sine, you have to be in the fourth quadrant. Okay. So that you're in the fourth quadrant, we want to figure out what angle it is in the first quadrant, and then really just make it negative. Because if you rotate whatever it is, let's just say it's pi over 4. Well, whether you rotate this way pi over 4 or this way pi over 4, this is just positive, this is just negative. You're not rotating the whole way around the circle like maybe we had when we first learned about the unit circle. So where does the sine equal 1/2? Is really what you're asked to find. Before, we were taking the sine of something and figuring out what was the ratio of the sides that made up. Now we're going backwards. So where does the sine equal 1/2? Well, theta, to make it equal 1/2, has got to be pi over 6. And thinking of it the other way, the sine of pi over 6 is equal to 1/2. Now, since it's negative, got to be in the fourth quadrant, we just make the angle negative. We're not rotating the whole way around the circle here. It's not 11 pi over 6, because that wouldn't meet our domain restriction. See, our domain restriction for sine is between negative pi over 2 to pi over 2. Okay, negative 90 to positive 90. So we can't say 11 pi over 6 because it's outside of there, but it's really the same location. It's down in the fourth quadrant at an angle of pi over 6 is just negative pi over 6. Okay, so now let's do the same type of thing. Where does theta, the sine of theta equals the square root of 3 over 2 somewhere? what does theta have to equal? Well, it's positive, so we're going to be in the first quadrant. Okay, that's good to know. I always like to look to see whether it's first quadrant or a fourth quadrant for inverse sine or arc sine. Again, same thing. Okay, so where does the sine, what angle makes the sine of some angle equal the square root of 3/2? All right, so what angle is that? That's got to be pi/3. All right, the 30, 60, 90 triangle is actually a 60, 30, 90 triangle if you want to think about it that way. So that is pi/3. Okay, and so let's go to the next one. Where does the sine, what angle will make the sine equal 2? Doesn't. It's not possible. So this, we would call this a domain restriction, domain error, undefined, however you want to say that, but the sine can never equal 2. The sine, if you think about the sine graph, it goes up to 1 and down to -1. It can't equal that. So that's a domain restriction. Okay. So now we take that concept and we're going to just look at cosine and tangent. It's just we were focused on sine to start because we could stay in one area, but now we're looking at cosine. So again, arc cosine and inverse cosine really mean the exact same thing. So where does the cosine equal the square root of 2/2? So again, what angle is making this true? And for cosine, we have to be in the first or the second quadrant. Okay. When we get the tangent, we got to be in the first or the fourth based on whether it's positive or negative. So where does the cosine equal the square root of 2/2? That's its some angle pi/4. And since it's positive, we're in the first, so it is just pi/4. If it were negative, then it would be in the second quadrant. That would be 3 pi/4. Where does cosine equal -1? So what angle makes the cosine equal -1? So where does the cosine equal -1? If you think back to your graph, it equals, that's the valley in our graph. If you go mountain, valley, mountain for a cosine graph, there's your cosine graph. Okay, so it's down here. That happens at pi. Okay. Now we need to look at tangent. So where does the tangent equal 0? What angle makes the tangent equal 0? And again, remember, you have to be between -pi/2 and pi/2, and it's 0. Think back to your tangent graph. It goes through 0, 0. So some of the stuff that we've been working on with graphing is going to help with this, and some of the stuff with unit circle is going to help with this. It's really just working backwards is really all you're doing. So where does the tangent equal -1? Well, forget about the negative for a second, because really that's only going to be in the fourth quadrant. It's only going to make the angle negative. But where does the tangent equal 1? Well, that's at pi/4. But since we're in the fourth quadrant, it's -pi/4. Okay. So again, we're just using the unit circle really and going backwards. We can use our graphing concepts to help with this as well. When we did the unit circle, we would take the cosine of pi/4 and try to find square root of 2/2, or you take the cosine of pi and try to know that it's -1. Take the tangent of 0, know that it's 0. Take the tangent of -pi/4 and know that it's -1. Now we're just going in backwards. That's all. Okay. So now we're going to just use a calculator. Okay, so we're going to pull up our calculator here. And before I do anything, I need to know what mode I'm in. So I look here, this is in radians. Okay. And then that's going to be radians, and that's going to be radians because I'm in radians. So I go to my handy dandy calculator, and the first one was arctangent. So let's go inverse tangent. We don't have an arctangent button on the calculator. We have an inverse tangent. So I find that in second tangent of -8.45, -8.45. And then I hit enter. So it's -1.453. And it says 4 decimal places, so I guess that would be 0. Yep. So I'm going to put the 0 in there because they told me to. All right. So now I have the inverse tangent of 0.2447. Okay. So inverse sine. There's an inverse sine button. And 0.2447, 0.2472. Okay. And then we're going to look at the arc cosine. We look at the arc cosine of 2. So we're going to go on our calculator and do the inverse cosine of 2, and we get a domain restriction. And that shouldn't be surprising because we can't take the inverse cosine of a number bigger than 1 or a number smaller than -1. So I'm just going to say domain restriction. You can call it undefined. I think either one of those makes sense here. Okay. Hopefully that makes sense. How would you know if you wanted to be in degrees? If you were dealing with a problem that had a triangle in it, like right now, I don't see any triangles. So I'm going to stay in radians, especially these two, because they say arc. This one, you could maybe make an argument, maybe it should be in degrees. But again, there's no triangle. So that's when I really don't think I want it as a degree in terms of like 25 degrees, 30 degrees, 100 degrees, or anything like that. Okay. So now we're going to use inverse properties to calculate these. Okay. So we're trying to find the tangent of the arctangent of -5. So when I look at this, I'm looking at, can I do an arctangent of -5? The answer is yes. So I have to pay attention to my domain restrictions again, because this still might not be possible. But with arctangent, we don't have any. We don't really have any domain restrictions in terms of numbers we can evaluate that way with the tangent. So if you're finding the arctangent of an angle and then you're taking the tangent of that, it really just ends up canceling out and becoming -5. These two are canceling each other out. Okay. It's like 5 steps forward, 5 steps back. So it's just -5. The same thing is really going to happen here, but I do need to be careful. Okay, so I need to evaluate the sine of 5 pi over 3, and then I need to take the arc sine of that. So these two somewhat cancel out. But we need to be careful because I can't get an answer of 5 pi over 3. Because that's outside of my domain with the arc sine, right? With the arc sine, I need to be in the first or in the fourth quadrant. So the way that I think about it, we're going to get 5 pi over 3 when they cancel, which is down here. It's this angle. So that's 5 pi over 3. Not allowed to have that, but it is the same angle. I just need to find this piece. Like, what is this angle in terms of it being negative? Well, this is 5 pi over 3. This is -pi over 3. So the answer is -pi over 3. They are essentially the same answer, except for I'm just not allowed to write that, if that makes sense, because it's outside of my domain restrictions. Remember, I have to be in the first quadrant rotating this way or in the fourth quadrant rotating this way. I'm not allowed to rotate all the way around because I cross over the second and the third quadrant. I'm not allowed to do that. I either got to be in the first or the fourth, and I got to go directly to the fourth. That's why it's -pi over 3. So when I look at letter C, you might think the answer is just pi. Again, we got to be careful because there's certain domain restrictions. Can you do the inverse cosine of pi? Well, remember, pi is 3.14. Can you do the inverse cosine of 3.14? Well, remember what we tried to do when we did the arc cosine of 2. We got a domain restriction. I'm going to get a domain restriction here as well. Can't take the arc cosine or the arc sine of a number bigger than 1. So anytime you try to do that, you're going to get a domain restriction. Okay, so we have to check the domain restriction first before these two cancel out. Just to quickly throw another example in here, if you were trying to find the cosine of the arc cosine of, I don't know, just another 1/3. Well, then that answer is just 1/3, because you can evaluate the inverse cosine of 1/3. Whatever that angle is, I don't know what it is off the top of my head. It would be a calculator question. That's not on the unit circle. But then you would take the cosine of that angle and you would get back 1/3. Okay, so just a quick example there, but that doesn't run into a domain restriction. So that's the key piece there. Okay. So down here, when you see tangent of an arc cosine, they don't cancel each other out. So this is a different type of question. When you see the same two inverse functions, know that they're going to cancel, and somehow it's either just going to be whatever this is the answer, or you just need to define it in one of the two quadrants that we're allowed to be in, or it's going to be a domain restriction. Those are really the three things that can happen when you have a trig function and then its inverse, or an arc trig function and its regular trig function. But down here, they're not going to cancel out because tangent and arc cosine don't cancel. Cosine and arc sine don't cancel. So I need to look at my arc cosine, and I need to be ready to make triangles and use Pythagorean theorem, because that's really basically what we're going to do. So ignore the tangent and just focus on this piece first. The arc cosine of 2/3. So I'm going to draw a triangle, and it's positive. Where's the arc cosine? Positive in the first quadrant. Okay. If it were negative, I would go to the second quadrant. So I'm in the first quadrant. What is cosine in terms of SOHCAHTOA? That's the CAH, C-A-H. So this is adjacent over hypotenuse. So the adjacent side is here. The hypotenuse is here. Well, now I need to find my other side. So Pythagorean theorem says 3 squared equals 2 squared plus b squared. So this is 9 equals 4 plus b. So 5 equals b squared. So this side is the square root of 5. Okay. So keep in mind, here's your angle of interest. What is the tangent of this triangle? Because isn't that what we're asked to find? We're asking the tangent of this. Well, what is this? This is this triangle. So find the tangent of this triangle. Well, what's the tangent of this triangle? Tangent is opposite over adjacent. So the answer to this is just the square root of 5 over 2. Again, we're finding the tangent of this. Well, this is this. So find the tangent of this, and you get that. All right. So now let's try this one. So we're going to take the cosine of the arc sine of this information. Remember, arc sine is we know the sides, we want to find the angle. In these two problems, we don't need to find the angle. It's not important to know exactly what this angle is, or when I draw my triangle over here, what the angle actually is. We're really interested in just the sides. So the arc sine, we got to be in the first or the fourth quadrant, right? For arc sine, we got to be in one of these two. Okay. So what's the cosine of this? So let's draw our triangle. It's negative. That means we got to be down here. And then what is sine in terms of SOHCAHTOA? So this is opposite over hypotenuse. Well, find my third side of the triangle. Hopefully you know that it's a Pythagorean triple. If not, do Pythagorean theorem again. So there, it's 3, 4, 5 triangle, Pythagorean triple. Okay, so again, this is our angle of interest. What is the cosine of this triangle? That's what we're really finding. Find the cosine of this. Find the cosine of this, because this triangle is just this information. Okay, so what's the cosine of this triangle? Cosine is adjacent over hypotenuse. And we're in the fourth quadrant, so cosine's positive. All right, so that is inverse trig functions, evaluating, calculating. If you have any questions, please let me know.